right?
Mm-hmm.
Okay. Now symmetric matrix, skew symmetric, that also I have explained.
Yes, ma'am.
Okay, so symmetric matrix is such a matrix when suppose we are having a matrix A, okay, then we will do the transpose of A, which can be written as A dash or maybe A transpose. That must be equal to
A
okay,
transpose must be equal to A, yeah?
yeah, A, and that's called symmetric matrix.
Yes, ma'am.
And when we are having the same matrix, suppose another matrix B we are having, where we are finding the
Mm-hmm.
transpose of B,
Uh-huh.
that, then we are getting negative of B, that called skew symmetry, right?
Mm-hmm.
Yeah, let's continue. So A is given over here. Prove that A minus A transpose is a skew symmetric matrix. We can clearly see a square matrix we are having over here, right?
Yes, ma'am. So A
Okay.
transpose will be the mirror of the thing, yeah? Like the...
Yeah, we will change this row, we will take as a column. Okay, the
Yeah, yeah,
next
yeah,
row
yeah.
we will take as a
Row will
column.
be column.
That's A transpose. Okay, we are
Okay.
supposed to
Yeah.
find A minus A transpose. So
Mm-hmm.
let's find quick A minus A transpose, just basic
Yeah.
subtraction we have to perform over here. Just a
Yes,
second.
ma'am.
Yeah. So our A is 2, 3, 4, 5, and A transpose is just minus 2, 4, 3, 5. Directly we can do the subtraction. So 2 minus 2
Mm-hmm.
is 0. Okay, 3 minus 4 is negative 1. 4 minus 3 is 1. And 5 minus 5 is 0. And
Yes, ma'am.
the resultant which we have got just now, okay, we are supposed to show that are we end up like the resultant which we are having, is it a skew symmetric matrix? That's what we are checking over here. So let's
Yes, ma'am.
suppose the resultant, this matrix which we are having in hand, this is q. Okay, this one is q.
Mhm. So Q transpose we'll have to
Q
find.
transpose will be, just we have to change the
Q
rows.
transpose will be 0, 1. Yeah. Q transpose will be 0, 1, minus 1, 0.
Yeah, okay, this is Q transpose. Now we will
Yes.
check whether this Q transpose is equals to negative Q. Can we say this is same as a negative
Yes.
Q?
Yes. Yes,
Now
ma'am.
let's
If you multiply with negative 1, you can get, yeah.
okay, negative 1, and here we'll be getting just 1, here just 0. So yeah, this is nothing but just negative Q, and yes, it is skew symmetric matrix, right?
Mm-hmm. Yes, ma'am.
Okay, let's do few more questions. And here, for the matrix A, find A plus A transpose and verify that it is symmetric. So directly I am writing A plus A transpose will be just our A is 2, 3, 5, 7.
Mm-hmm. 2, 3, 5, 7. 2, 5.
A transpose,
2, 5, 2, 2, 5, 3, 7. Yeah. So I'm
yeah, 2,
adding, we'll
5,
get 4.
right?
Yes, 2, 5, 3, 7. Yeah. Transpose.
Right? Okay. So
Yes.
we'll be adding 2 plus 2, 4, 8, here 4, 8, here 8, here 14. And we are checking, is it
Us.
symmetric? So suppose this one, the resultant is, again I'm telling that this is Q
Q.
or maybe P. So if we will just find the transpose of the resultant, the final matrix Q, so will it be same as a Q transpose?
Mm-hmm.
Q transpose and Q are same, right?
Mm. Yes, ma'am. Yes. They are the same.
Okay, so what I'm trying to say that you will take any square matrix, and when you will add the transpose of that with the same matrix, always your resultant will be a symmetric matrix. Always, it is not just valid for this A. Even if you are having a 3 by 3 matrix, still when you will take the transpose of that matrix, okay, if you are having a matrix B, which is suppose a 3 by 3 matrix, if you will take the transpose of that, and if you will add this B with B transpose, always your resultant will be a symmetric matrix. Getting it?
Okay, ma'am. Yes, ma'am.
Okay, and with the help of that first question which we did just now, there we had done the subtraction, and the proving part was show that it is a skew symmetric. So that question is trying to tell us that if we will have any square matrix, okay, and if we will find the transpose of the same, and when we will do the subtraction of these two, always our resultant will behave like a skew symmetric matrix. Always.
Okay. Yeah.
Okay, we just need to take a square matrix. Okay, then A plus A transpose will always be symmetric, and A minus A transpose will always be skew symmetric. Okay, now
Mm-hmm.
this question is saying that express the matrix A as sum of a symmetric and a skew symmetric matrix. Okay, express this A as sum of a symmetric
Okay. And a skew
and
and a skew symmetric matrix. So these two matrices, the symmetric wala and the skew symmetric, they have to be the same matrix?
uh, can you please repeat?
No, this the sum, yeah. Like A is made, we have to show that A is the sum of two different matrices, you know?
Yeah. Huh.
Symmetric and a skew symmetric matrix.
Yeah, the first has to be symmetric. Any matrix, just it has to
Oh,
be
okay,
symmetric.
okay, okay,
And
okay.
the other one, any matrix, it has to be skew symmetric, given the condition that both added together will make it.
Mm-hmm.
Okay, so this here we will use our logic that if we are having a 3 by 3 matrix, or a square matrix when we are having, then
Okay, ma'am.
always whenever we will do A plus A transpose, it will be symmetric, right?
Mm-hmm.
And when we will do A minus A transpose, it will be skew symmetric.
Yes, yes.
And from here only we are trying to do the arrangement. Just a second.
Okay, okay, okay.
Yeah. So now we are trying to do one arrangement, that what if we will take this two added together, will it give us A or not? So see, if we will take the first bracket, this one, okay, this one I have taken, and when I will take the other one, added, both added together, then see what are we going to get. Okay, when we will open the bracket here, when we will do the calculation, we will open the bracket A plus A transpose plus A minus A transpose. Are you realizing, Ibrahim, that A transpose will cancel out each other?
Yes, yes, they'll cancel. So
Okay,
A
and we will end up
matrix
having
plus,
two
yeah,
A. We
yeah.
will end up having two A, but we want just A.
Mm-hmm.
Okay, because in the next question it is saying that just make A is equals to sum of a symmetric and a skew symmetric. So if here we will manage to just take out A, then the same thing we can do in the next question, right?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
we are trying to say that rather than taking just A plus A transpose and A minus A transpose, from now onward we can take 1 by 2, a scalar we are just multiplying. See, if you are having symmetric matrix, you will do the multiplication of a scalar, nothing will change, still it will be symmetric.
Yes.
If you will do the multiplication of scalar in skew symmetric matrix, nothing will change, still it will be skew symmetric, because we are multiplying with each and every element of the matrix, right?
Mm-hmm.
Okay, so we are doing this arrangement, and now we are thinking, now we will open the bracket, so we will be having 1 by 2A plus 1 by 2A transpose plus 1 by 2A minus 1 by 2A transpose. this gone.
Yes, ma'am.
1 by 2 है, 1
Yes, yes, yes.
just a, and we are able to represent, this a matrix A as a sum of symmetric and skew symmetric matrix. If we understand this logic, then we can say A can be written as 1 by 2 A plus A transpose
Yes, correct.
plus
Yes,
1
ma'am.
by 2 A minus A transpose. We don't need any other matrix. Okay, a new matrix we will be able to make with the help of A only. We don't have to think about any other thing, right? Right?
Mm-hmm. Yes,
I,
ma'am. Yes, ma'am.
is it making sense?
Yes, yes, ma'am. Yes.
Okay, so this
Mm.
is symmetric, this is skew symmetric. Previously we were taking just A plus A transpose and A minus A transpose, but since we want to make it A, we have taken half. Again, if you want to read the
Okay.
question, please read the question. Express the matrix A as the sum of symmetric and skew symmetric. So one new
Mm-hmm.
matrix, another new matrix, given the condition is first is symmetric, okay, another is skew symmetric, and both added together is giving us A. And this is the
Okay.
best way to get this type of arrangement. Got it?
Yes, ma'am. Yes, ma'am.
Let's finish it. So this type of question will be there in your exercise. You will be able to do it by yourself as well. So A is given over here, and we'll be finding A plus A transpose. Okay, A minus A transpose. That's it. And 1 by 2 we will multiply. Okay, we can say that these two are the matrix, okay, which taken as one is symmetric, another is skew symmetric, and yeah, definitely it will give us A. Okay, we can show as well. So let's do it. Let's finish it.
Mm.
Our
Okay,
is
ma'am.
2 minus 2. Here I am finding A plus A transpose and A minus A transpose. And directly here only let's do the solution. So A plus A transpose. Our A is 2 minus 4, negative 1, 3, 4, 1 minus 2 minus 3. And we'll be having plus A transpose, that means 2 minus 2 minus 4 minus 1 3 4, whatever way you write. Okay, it has to be, just we are changing the column to row or maybe row to column, it's the same thing. Okay,
Okay, yes, ma'am.
this is what we are getting. This 2 plus 2 is 4, minus 2 minus 1 minus 3, minus 4 plus 1 minus 3, minus 1 minus 2 minus 3, 3 minus 3 0, 4 minus 2 2. Please keep on checking. Okay, 1 minus 4 is negative 3, minus 2 plus 4 is just 2, minus 3 minus 3 is minus 6. Okay, and we want to multiply 1 by 2 over here, then only we will be getting, right?
Yes, ma'am.
From each number we will be just dividing by 2. Okay, so 4 will become just,
Mm-hmm.
this is,
1 minus 1 minus 2.
no,
Okay, we can.
we are dividing by 2, so this will
Yeah.
be minus 3 by 2, right?
No, no, no. Yeah, yeah, yeah. No, no, I'm going row wise. That's why.
Okay,
So we get 1 minus 2. That's one.
okay. So we are dividing like scalar multiplication. We are doing 1 by 2. This is what we are going to get. 0 will be 0. This will be just 1. Okay. This will be just 1. And this will be minus 3 by 2. And this will be minus 3. Right, Ibrahim?
Yes, ma'am.
Any confusion so far?
Mm-hmm. No.
Okay. So basically this is what? This is 1 by 2. A plus A transpose. Similarly, we will do 1 by 2. A minus A transpose. And we will show. Okay. We'll be getting A. Will you be able to do it by yourself?
Yes, ma'am. Yes, ma'am. Easy.
Okay, I'm leaving it. Let's finish. Find the transpose of each of the following matrix. You'll be able to do, right? A and B are given, then verify this is equals to this. Yeah, okay, you'll be able to do. You just have to do A plus B. both added together, then transpose, that will be same as A transpose plus B transpose. We write transpose as this one, or maybe we write transpose as this one. These two are same thing. Okay. Next.
Okay, yes, ma'am.
Yeah. Now this one, number 3. Here A transpose is given and B is given, and we are supposed to verify that A plus B transpose. See, A, how we will get A, Ibrahim? We don't have A, we have A transpose.
Mm-hmm.
How we will get A?
A transpose. So A transpose, we'll find out the transpose of A transpose.
Yeah, we will do A transpose, that transpose again, and we will end up getting A.
Yes,
That A
ma'am.
we can add with B, and then we can proceed in the same manner. Now, this one A transpose and B is given. Yeah, you will be able to do this one as well. If the matrix A and B verify that this one, you will be able to do. This one also you will be able to do. This one also you will be able to do. For the matrix A, verify that. Yeah, this one just now we have discussed that always for a square matrix. Okay, A plus A
Mm.
transpose has to be a symmetric matrix. It's not just for this question. It will always be symmetric matrix, right?
Yes, ma'am.
Okay, and A minus A transpose is skew symmetric. Now this question you can clearly see, find this one and this one when A is given. So yeah, we'll be able to find. Basically, one of them will be symmetric and another will be skew symmetric. Okay, we don't have to just go that much deeper. We just need to find the values as asked in the question, right?
Mm-hmm. Okay, ma'am. Yeah.
Express the following matrices as a sum of symmetric and skew symmetric. So each matrix we need to write as sum of symmetric matrix and skew symmetric matrix.
Mm-hmm.
Okay, each one we will be doing in the same manner. Let's do this one, the next one. Choose the correct answer in the given exercise. So A and B are symmetric matrix of the same order. Okay, then AB minus BA is AB minus BA is
0.
0. Let's see. A and B are symmetric matrix. If A is symmetric, we can write A and A transpose will be same, right?
Yes, yes.
Okay. And if B is symmetric matrix, we can say B and B transpose, it's same matrix, right?
Mm-hmm.
Okay. And we want to check what about this AB minus BA. Options are symmetric, skew symmetric. So AB minus BA, if you are writing as a Q, so basically you want to check whether Q transpose is same as minus Q or plus Q, right?
Yes.
Okay. So do we want to find the transpose of AB minus BA? Yes. Okay. Let's
Yes,
find it
yes, yes.
like this. So transpose rule says that when addition is there, when subtraction is there, we can just distribute it in the like very basic manner like this, right?
Yes, yes.
Okay, we are just trying to check what about Q transpose. Okay, so now multiplication property says that we'll be taking B transpose first and then A transpose, right?
Uh-huh.
Okay, and here we'll be getting again A transpose first and then B transpose, right?
Yes, yes.
Here B transpose, we know B transpose and B are same, so even if we are replacing B transpose with B, it's okay. Okay, if we are replacing A transpose with A, it's okay because A and B are symmetric, right?
Ah, yes, ma'am.
Now A
Yes,
transpose can
yes, yes.
be written as A and B transpose can be written as B. So basically when we found the transpose of AB minus BA, the original matrix AB minus BA, we got BA minus AB. So can I say this is nothing but minus of AB minus BA? Can I say?
Yes, 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 ma'am.
Because when we are having algebra, when we are dealing with algebra, a minus b can be written as minus of b minus a, right? We are doing
Yes,
one
ma'am. Yes, ma'am.
arrangement, or we say that we are taking minus common, so we can write it this way. So basically we ended up getting q transpose is minus q, right?
Yes, ma'am.
So it is,
Yes,
it
ma'am.
is skew symmetric, right?
Mm-hmm.
Getting it?
Yes, ma'am. Yes, ma'am.
Okay, it is a skew symmetric. When we are having a matrix A which is symmetric, we have written that. A matrix B which is symmetric, we have written the condition, whatever we understand from symmetric. Now here we have proved that AB minus B is symmetric or skew symmetric. We were trying to check, so we thought first let's do the transpose, then only we will be able to see whether same thing we are getting or negative we are getting. So we ended up getting negative. Okay,
Mm-hmm.
the last one over here. If A is given over here and A plus A transpose is equals to I, then the value of alpha, okay, A plus A transpose is I. Our A is cos alpha minus
Yes.
sine alpha,
Yes, ma'am.
cos alpha, okay, and A transpose is just the same, cos alpha minus sine alpha, just sine alpha and cos alpha, right?
Mm-hmm.
Prime. If we
Mm-hmm.
will add this two, what are we going to get? If we will add this two, we are going to get cos alpha plus cos alpha, 2 cos alpha, right?
Yes, ma'am.
Okay, sine alpha,
Yes.
one is negative, another positive, 0. Sine alpha,
Zero.
0. Cos alpha,
Zero.
cos alpha. And
Cos
that is
alpha.
equals to I, identity matrix. So we must take identity matrix of order 2 by 2. Okay, that means 1, 0, 0, 1, right?
Mm-hmm.
If we will compare it with 1, 0, 0, 1, we can clearly say, okay, this 2 cos alpha, 0, 0, 2 cos alpha. That is equals to 1, 0, 0, 1. We can say 2 cos alpha is 1, cos alpha is 1 by 2. And here we will be getting from the trigonometric table, we'll be getting alpha value very easily, right?
Yes, ma'am.
Any confusion
Yes.
so far, Ibrahim?
No. No, ma'am. No.
Okay. Next question. It says that A and B are symmetric. A and B are symmetric matrices of same order. Then show that. Wait,
Uh-huh.
let's see the complete question. Yeah. If A and B are symmetric matrices of same order, then show that AB is symmetric. If and only if A and B commute. Okay. That means AB is equals to BA. Commutative property you have learned in lower classes as well. Okay, it says when we are saying any whole number follows commutative property for addition, that means 3 plus 4 and 4 plus 3 is same, right?
Mm.
If it follows commutative property for multiplication, that means 3 into 4 and 4 into 3 is same, right?
Yes.
Okay, so that's what it says, that A and B are symmetric matrices. First, whenever the moment we have read this statement A and B are symmetric, we will write that if these two are symmetric, A transpose is same as A and B transpose is same as B, right?
Yes. Yes.
Okay, both are having same order, fine. Then show that AB is symmetric. So we are supposed to show this time AB. Okay, AB.
Mm-hmm.
So AB is symmetric or skew symmetric, that we will be able to check once we will find the transpose of AB, right?
Yes, ma'am.
Okay, so that means do we need to take transpose of AB? Of course. Okay, then we need to use the property. Property says that we are supposed to take B transpose. We are supposed to take A transpose. Like that, we can open the bracket, right?
Mm-hmm.
Okay, now B transpose and B are same, so we can write B transpose as B. We can write A transpose as A, right?
Yes, ma'am.
So we ended up getting, we started with AB. Okay, we have done the transpose and we ended up getting BA. And here the question says that it will be symmetric if AB and BA are same. So instead of this BA, if I can write AB, okay, AB transpose
Mm-hmm.
AB, then I can say, yeah, it is symmetric, right?
Yes, ma'am. Yes,
Okay,
ma'am.
so here only we will write that yes, AB is symmetric if and only if AB is equals to BA, right? Because we
Mm-hmm.
understand in matrix it doesn't happen always. A into B and B into A is not same. Okay, it doesn't, like, the
Yes, ma'am.
multiplication of two matrix will, like, may be same, may not be same, but always we cannot say it will be same. Okay,
Yes, ma'am. Yes.
there has to be a valid reason when we are saying BA and AB are same. So here it says that this will be symmetric when BA and AB are same, and we are getting the same scenario, so we will write that. Yeah, got it.
Mm-hmm.
Okay, let's move.
Yes, ma'am.
This one, A, B are symmetric. Again, so A and B are symmetric means A is A transpose. Both are same. That means A transpose A or A transpose. Whatever way you write, it's same, right?
Mm-hmm.
Okay, then prove that this. So this means what? AB minus B. Okay, just now we have done this question, right?
Yes, ma'am.
Okay, just now we have done, we say that this will take the transpose, this will take the transpose. Then this one can be taken as B transpose A transpose. This one can be taken as A transpose B transpose. Subtraction sign as it is. This will be BA. This will be AB. Okay, we started with AB minus BA, and now we are having BA minus AB. Minus sign we have to take common. It will be skew symmetric, right?
Yes, ma'am.
Next, show that B transpose AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. What can be done over here, Ibrahim?
If A and B are symmetric,
This one.
prove that.
This.
Okay, show that the matrix B transpose, yeah, B
Yeah.
transpose multiplied by A multiplied by B is symmetric or skew symmetric according as A is symmetric, or show that the matrix B dash AB is symmetric or skew symmetric accordingly as A is symmetric or skew symmetric.
So basically, we are supposed to show this one. This one is symmetric or skew symmetric. You understand Hindi as well, right?
Yes, ma'am. Yes, ma'am. I'm from Bombay.
ओके, इट सेज दैट यहाँ पे क्वेश्चन में ये बोला जा रहा है कि ये
Mm-hmm.
जो बी ट्रांसपोज ए बी हमारा इन तीनों को मल्टीप्लाई करके एक फाइनल हमें कोई मैट्रिक्स दिखेगा, राइट?
G.
इस सिमेट्रिक, ये जो मैट्रिक्स हमें फाइनली मिलेगा ये
Uh-huh.
सिमेट्रिक होगा, या तो
Mm-hmm.
सिमेट्रिक होगा या फिर स्क्यू सिमेट्रिक होगा अकॉर्डिंग, ओके? ये
G.
सिमेट्रिक होगा या स्क्यू सिमेट्रिक होगा कब? जब हमारा ए सिमेट्रिक होगा तो हमारा फाइनल वाला मैट्रिक्स सिमेट्रिक दिखेगा। ओके, मतलब ये ए पे डिपेंड करेगा, ए पे डिपेंड करेगा। अगर हमारा ए सिमेट्रिक है तो हमें बी बी ट्रांसपोज ए बी सिमेट्रिक दिखेगा। अगर हमारा ए
Yes.
स्क्यू सिमेट्रिक है तो हमें ये जो फाइनल रिजल्ट यहाँ पे दिखेगा ये स्क्यू सिमेट्रिक दिखेगा। मतलब ये ए पे डिपेंड करेगा, ऐसा शो करके दिखाओ क्या ऐसा होगा
Yes, ma'am.
या नहीं होगा। ओके, अगर हमारा ए
G.
सिमेट्रिक है तो ये फाइनल वाला रिजल्ट भी सिमेट्रिक ही होगा। अगर हमारा ए स्क्यू सिमेट्रिक है तो ये जो फाइनल वाला रिजल्ट है ये स्क्यू सिमेट्रिक ही होगा। तो हम इसे
Okay. G.
समझ में आ रहा है इब्राहिम?
G. 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 G.
ओके, सो वी कैन टेक बी ट्रांसपोज ए बी, जस्ट अ मिनट।
यस मैम, फिनिश्ड हो गया मेरा। बोलूं?
Yeah, you said anything?
Okay. I finished. So, if we assume A is a symmetric matrix, if we assume A is a symmetric matrix,
Hmm.
so A will be equal to A transpose.
Hmm.
Is
Yeah,
that right?
yeah.
A will be equal to A transpose.
Hmm.
Then B transpose into AB. If we'll take the transpose of the whole thing,
Hmm.
so we'll get B. No, we can take AB is equal to Q. Let's say if
Hmm.
we take AB is equal to Q, so B transpose Q the whole transpose. So
Hmm.
that will give us Q transpose into B. Is that right? Q
Yeah.
transpose into B.
बेसिकली हमें लास्ट से लेना होता है, ओके?
जी जी जी।
तो हम ऐसे ऐसे कुछ ले सकते हैं, जस्ट एज
हम्म।
दिस बी ट्रांसपोज दैट्स अगेन ट्रांसपोज, राइट?
यस। ओके जी मैम।
क्यू तो हमारा ए बी था, राइट?
हम्म।
तो ए बी लिख दे हम क्यू के प्लेस पे, और बी ट्रांसपोज ट्रांसपोज का मतलब जस्ट बी होगा, राइट?
जी।
फिर हमें कैसे ट्रांसपोज, जब भी हमें दो दो मैट्रिक्स मल्टीप्लिकेशन में हो और ट्रांसपोज हो, तो हमें रिवर्स वे में रिवर्सल रूल अप्लाई करना होता है, राइट?
हम्म।
तो यहाँ से हमें क्या मिलेगा? ए ट्रांस वेट
जी।
बी ट्रांसपोज इंटू ए ट्रांसपोज, यहाँ से बी ट्रांसपोज इंटू ए ट्रांसपोज, राइट इब्राहिम?
हम्म।
और ये जो बी है वो एज इट इज रहेगा,
जी।
ओके? तो हमने कहाँ से स्टार्ट किया था? यहाँ से। हमें क्या मिला? दिस वन, ओके? देखो ध्यान से, हमें बी ट्रांसपोज हमारा एज इट इज हमें दिख रहा है, ओके? ए के प्लेस पे ए ट्रांसपोज इस बार दिख रहा है, और बी के प्लेस पे फिर से बी। मतलब अब ये ए ही डिसाइडिंग फैक्टर है। अगर ए और ए
हम्म।
ट्रांसपोज सेम है,
ए
ओके,
एंड ए ट्रांसपोज सेम है तो वी कैन, हम लोग
तो
ने।
हम कंक्लूड कर सकते हैं कि ये जो मैट्रिक्स है फाइनल, ये क्या है? सिमेट्रिक है, राइट?
जी जी जी। तो हो गया। हाँ,
ओके, क्लियर?
जी जी।
इज इट क्लियर?
यस मैम, यस मैम, यस मैम।
अगर हमने ए को स्क्यू सिमेट्रिक मान लिया होता, जैसे कि ए ट्रांसपोज इज इक्वल्स टू माइनस है, ओके, और
हम्म।
फिर हमने ये सारी चीजें की होती, फिर से हम और एक बार दिखाएंगे, क्योंकि यहाँ पे हमें यही शो करना है कि डिपेंड कर रहा है ए के ऊपर। अगर ए सिमेट्रिक है तो हमारा ये जो फाइनल रिजल्ट है ये भी सिमेट्रिक होगा, अगर ए स्क्यू सिमेट्रिक है तो हमारा फाइनल रिजल्ट स्क्यू सिमेट्रिक होगा। तो मैं लिख रही
जी।
हूँ बी ट्रांसपोज ए बी, अगेन ट्रांसपोज हम ले रहे हैं और चेक कर रहे हैं सिमेट्रिक आएगा या स्क्यू सिमेट्रिक। सो वी आर गोइंग टू गेट, ओके, रिवर्सल रूल हमें, ओके, हमें फ्रीडम देता है दैट इफ वी आर हैविंग ए बी सी ट्रांसपोज, देन वी कैन राइट सी ट्रांसपोज बी ट्रांसपोज ए ट्रांसपोज, ओके?
हम्म।
तो हम डायरेक्टली भी लिख सकते हैं, या फिर अगर हमें क्यू लेके अच्छे से क्लियर रह रहा है तो हम क्यू सपोज करके भी प्रोसीड कर सकते हैं। सो वी कैन राइट बी ट्रांसपोज, then we can write a transpose, then we can write b transpose whole transpose, right?
हम्म।
Okay, B transpose को just let's keep as it is. A transpose, okay, I'm just keeping as it is for now. B transpose whole, again transpose will be just B, right?
हम्म।
Okay, फिर से हमें,
ओके जी मैम।
हमने जहाँ से स्टार्ट किया था हमें कुछ वैसा ही मिल चुका है, बस दिस A is the deciding factor, right?
हम्म।
अगर ये जो A है ट्रांसपोज विल गिव अस माइनस ए, इस ए ट्रांसपोज के प्लेस पे अगर हमने माइनस ए लिखा, और बेसिकली जब हमें माइनस लिखना है, मल्टीप्लीकेशन हम कर रहे हैं, दैट माइनस वी कैन राइट इन एट द फ्रंट, राइट?
जी।
ओके, सो वी
या।
आर गेटिंग दिस। अब हमें क्लियरली दिख रहा है जहाँ से हमने स्टार्ट किया था और जो हमारे पास है अभी, दिस इज स्क्यू सिमेट्रिक, क्लियरली इट इज रिप्रेजेंटिंग स्क्यू सिमेट्रिक। अगर ए स्क्यू
हम्म।
सिमेट्रिक था तो हमारा रिजल्ट भी स्क्यू सिमेट्रिक निकल के आ रहा है।
जी 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 जी। ओके।
क्लियर?
जी।
लेट्स मूव। Find the value of x, y, z if the matrix A satisfy this equation. You will be able to find, okay, we will be able to create equations. ओके, एंड फ्रॉम देयर यू विल बी लाइक ए ट्रांसपोज को ए से मल्टीप्लाई हम करेंगे और फिर आई से इक्वेट करेंगे। आई का मतलब होता है आइडेंटिटी मैट्रिक्स, 3 by 3 मैट्रिक्स है हमारे पास, तो हम 3 by 3 आइडेंटिटी मैट्रिक्स अज्यूम करेंगे, राइट। ओके, देन हमें यहाँ पे एक रिजल्टेंट मिलेगा इक्वेटिंग बोथ साइड। हम एलिमेंट बाय एलिमेंट इक्वेट करते हैं, मतलब हम A11 को A11 से इक्वेट करते हैं, A22 को A22 से, ओके, A21 with A21, okay, element by element we equate. We will be getting so many equations over here which can be solved further to take out the value of x, y, z, right?
G. Yeah.
Yeah, I'm talking about this question. If you want to read it by yourself, please.
Satisfy the equation. Yes, ma'am. Easy question. Easy question. We can do it.
Today I'll be activating all the assessments, okay, from matrix.
Okay.
Okay,
Okay, ma'am.
go ahead and give the assessment. Let's cover it. For what value of x this into this is equals to, okay, 0, a null matrix. Let's see. Okay, तो हमें multiply करना है with 1 to 1.
1 2 0 2 0.
Okay, this will be multiplying with this 1 2 0 2 0 1 1 0 2. हम sequence change नहीं कर सकते हैं. We are not dealing with algebra. We are dealing with matrices. Okay, so हमें row to column multiply करना होता है, right?
Yes.
Okay, so first
G
row
G
को
G.
first column से हम multiply करते हैं, मतलब 1 into 1,
Mm.
then 2 into 2, then 1
G.
into 1. This is the first. देन फर्स्ट रो को सेकेंड कॉलम से अगर हमने मल्टीप्लाई किया तो हमारा एलिमेंट, ओके, आवर एलिमेंट विल बी सिटिंग ओवर हियर। ओके, फर्स्ट रो का अभी जॉब खत्म नहीं हुआ, वी विल बी स्टिकिंग विथ फर्स्ट रो, और रिजल्टेंट में हमें जो जो भी हमें हमारा रिजल्टेंट दिखेगा वहां हमें फर्स्ट रो ही मिलने वाला है, राइट?
Mm-hmm. G G G.
ओके, सो 1
G.
2, then 2 into 0, then 1,
Mm-hmm.
next 1 into 0, 2 into 1, okay, 1 into 2. So just this much we are going to get. Are you getting it?
Mm-hmm.
We are getting
Yes. Yes.
2 times
That's
4,
exactly what I got.
6. 6, 2,
6 2 4 0 2 x is equal to 0.
4, 0, 2, x. Okay,
Yeah.
now doing the multiplication over here. Row to column. Okay, हमें
6
क्या
into 0
मिला?
plus 2 into 2 plus 4 into x equals 0.
6 into 0,
Yeah.
0.
2 plus 2 into 2 plus
2
4x.
plus 4. 4 into x plus
Yeah.
4x. बस, और कुछ हमें मिलने ही वाला नहीं है, राइट?
Mm-hmm.
ओके, एक ही एलिमेंट है। ये जो मैट्रिक्स है ये 1 by 1 मैट्रिक्स हमें मिला है। ओके, अगर हम इसे जीरो से कंपेयर करेंगे, अदर साइड में हमारा जीरो है, जस्ट जीरो। ओके, वी कैन कॉल इट इन मैट्रिक्स फॉर्म ऑल्सो, वी कैन राइट इट। सो बेसिकली वी आर हैविंग 4x plus 4 is equals to 0, और वहां से हमें x का वैल्यू मिल जाए, राइट?
Okay. Yes, ma'am.
नो कंफ्यूजन?
No, no confusion.
दिस वन इज ऑल्सो लाइक दिस वन इज ऑल्सो लाइक दिस।
X is minus 1, yeah, in that one.
या x is -1।
Okay.
A manufacturer produces three product, this. He sells in two markets. Market one is given, market two is given. If unit sell prices of X, Y, Z are this respectively, find the total revenue in each market with the help of matrix algebra. Okay, already the product
Mm-hmm.
given like this. We can take it in the matrix form, and this this is X, this is Y, this is Z, right?
Mm-hmm.
Now XYZ are given like this, rupees 2.50. Okay, unit sale prices are given 2.50 for unit, okay, product, 1.50 for unit product 1. Okay, and if we will do the multiplication, basically we need to do multiplication, right?
Mm-hmm.
Right? अगर
Yes, ma'am.
हम किसी शॉप पे कुछ भी बाय करने जाते हैं तो दो चीजें हमें पता होनी चाहिए कि एक एक पेन का प्राइस क्या है, राइट?
Mm-hmm.
और दूसरा, हमें कितना पेन चाहिए। हमने क्या डिसाइड किया, 20 पेन खरीदने के लिए हम गए हैं, या 50 या 60 या 100 या 200। ये दोनों
Mm-hmm.
फैक्टर डिसाइड करता है कि हमारा टोटल कितना बिल बनेगा, राइट?
जी.
ओके। तो यहाँ पे भी हमें वैसा ही कुछ बोला जा रहा है। ऑफ मैन्युफैक्चरर प्रोड्यूसेस 3 प्रोडक्ट। मैन्युफैक्चरर किसी फैक्ट्री में इतना प्रोडक्ट्स बन रहा है, और एक प्रोडक्ट का प्राइस 2.50 है, एक्स कैटेगरी वाले प्राइस प्रोडक्ट का, वाई कैटेगरी वाले
जी.
प्रोडक्ट का एक का प्राइस इतना है। ओके, ये नंबर ऑफ यूनिट्स रिप्रेजेंट कर रहा है, ऑफ कोर्स, राइट? नंबर ऑफ
Mm-hmm.
प्रोडक्ट, नंबर ऑफ प्रोड्यूस, राइट? और
जी.
एक
जी.
प्राइस 1 रुपीज है। तो बेसिकली हमें मल्टीप्लाई करना होगा टोटल प्राइस निकालने के लिए, टोटल रेवेन्यू, कितना टोटल रेवेन्यू निकल के आया, ओके, कितना इनकम हुआ, ये हमें मल्टीप्लाई करके पता लगेगा, राइट?
जी.
ओके। तो दिस इज हाउ वी कैन डू द मल्टीप्लीकेशन। नाउ मैट्रिक्स मल्टीप्लीकेशन करते टाइम हमें बस एक चीज का ध्यान रखना होता है कि क्या यहाँ मल्टीप्लीकेशन पॉसिबल है। मतलब
Mm-hmm.
नंबर ऑफ कॉलम ओवर हियर हैज टू बी सेम एज नंबर ऑफ रो ओवर हियर। अगर हमने अच्छे से अरेंज किया है, ओके, इफ दिस वे मल्टीप्लिकेशन इज पॉसिबल, देन वी आर डन। ओके, कॉलम हमारा यहाँ पे कितना है, 1 2 3, और रो हमारा सेकेंड में कितना है, 1 2 3, राइट?
Mm-hmm.
तो मल्टीप्लिकेशन तो पॉसिबल है। अब हमें क्या बताना है, फाइंड द टोटल रेवेन्यू इन ईच मार्केट। टोटल रेवेन्यू हमें बताना है ईच मार्केट में। तो ऐसा नहीं है सिर्फ कॉलम और रो मैच कर रहा है और बहुत सारे एलिमेंट्स हमारे मैट्रिक्स में रिजल्टेंट में दिख रहा है, तो हम नहीं बता पाएंगे दैट विच वन इज रिप्रेजेंटिंग फॉर एक्स व्हाट इज द टोटल रेवेन्यू, फॉर वाई व्हाट इज द टोटल रेवेन्यू, फॉर जेड
जी. जी.
व्हाट इज द टोटल रेवेन्यू। हम बता नहीं
Mm-hmm.
पाएंगे, राइट?
नहीं.
ओके, तो प्रॉपर हमारा रिजल्टेंट भी एक फॉर्मेट में दिखना चाहिए जहां हमें एक एक्स दिखे, एक ही वाई दिखे और एक ही जेड दिखे। तो जो रिजल्टेंट मैट्रिक्स आएगा वो उसका ऑर्डर कैसा होगा, चलो एक बार देख लेते हैं। ओके, बिना कैलकुलेशन किए। तो यहाँ पे हमारे पास कितने मैट्रिक्स है, रो, नंबर ऑफ रोज आर 2 एंड नंबर ऑफ कॉलम इज 3। नंबर ऑफ रो इज 1, वेट, 1 2 3, या, एंड नंबर ऑफ कॉलम इज 1, या। हमारा क्राइटेरिया है कि नंबर ऑफ कॉलम ओवर हियर हैज टू बी सेम एज नंबर ऑफ रो ओवर हियर, राइट?
Mm-hmm.
ओके, और हमारा जो रिजल्टेंट आता है वो क्या होगा, 2/1 होगा, राइट?
जी.
ओके, मतलब 2 रो होगा और एक कॉलम होगा, राइट?
Mm-hmm.
मतलब ऐसे अगर हमने मल्टीप्लाई कर दिया तो हम एक्स वाई जेड नहीं बता पाएंगे, राइट?
जी.
ओके, तो हमें थोड़ा सा समझ के ध्यान से मल्टीप्लाई करना होगा। अगर हमने इस वाले मैट्रिक्स को पहले रख दिया,
Mm-hmm.
और नो,
Okay. जी.
और मे बी इफ वी विल अरेंज दिस वन लाइक, जस्ट अ मोमेंट। इफ आई विल टेक दिस वन इन फ्रंट एंड दिस वन, या, देखो ऐसे मल्टीप्लाई करेंगे। Okay, still we are going to get 1/2. Just a moment now. Am I doing any mistake? Okay, total revenue in each market, और मार्केट तो हमारे पास दो ही है, हमें एक्स वाई जेड कैटेगरी वाला आंसर नहीं मिलेगा। कैन यू सी, मार्केट 1, मार्केट।
जी.
ओके, तो जैसे हमने स्टार्ट किया
Mm-hmm.
था ऐसे ही कंटिन्यू रखेंगे और हमें मिलेगा 2/1. ओके, मार्केट 1, मार्केट 2 का आंसर हमें दिखेगा. गेटिंग इट?
जी जी
बट ध्यान रखना, जो हम अरेंजमेंट यहाँ पे बात कर रहे थे, ऐसा हमें सोचना पड़ता है किसी मैट्रिक्स में,
जी।
क्योंकि रिजल्टेंट तो हमारा आ जाता है, लेकिन जो हमें चाहिए वो हमें क्लियरली दिखता नहीं है हमारे मैट्रिक्स में. ओके, तो हम ध्यान में रखेंगे कि हमें आंसर कैसा हमारा दिखना चाहिए इन मैट्रिक्स फॉर्मेट. ओके, is it making sense, Ibrahim?
जी 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 जी
Only how we will be doing the multiplication. The order over here is number of columns are 3 and number of rows are 2. Here number
जी
of is 1 and number of rows are 3. Clearly it is matching. Resultant will be 2/1. And yeah, we will be getting for market 1, for market 2, what is the total revenue. Clear. Let's move. If the unit cost of above three commodities are this, then find the gross profit. ओके, ग्रॉस प्रॉफिट का मतलब होता है जितना, वेट, if the unit cost of the above three commodities are this.
मैम 15,000 and 17,000 मार्केट 1 and मार्केट 2 जी है ना?
I need to check what exactly is the.
Okay.
Okay, I will be checking, just a moment. In the book I am checking. So if the unit cost 15,000 and 17,000 you have got after doing multiplication.
Yes.
Okay, let me check. It is it 15,000 and what you said?
17,000 I'm getting.
No, the answer is given different. Here it says the answer has to be 46,000 and 53,000.
No, that's total revenue, no? That's total revenue. We are finding total profit.
Wait.
Total revenue is 46 and 53.
Okay, so you are talking about the second part or the first part?
Second part, second part.
Okay, second part. So you have found the profit as well, right?
Yes,
Let
yes,
me
ma'am.
check the second part. Yeah, the second part has to be 15,000 and 17,000. Okay,
Okay.
so profit means total income. Okay,
Mm-hmm.
minus the price which we have paid while buying, right?
Yes.
Okay, so yeah, okay, the final amount is correct.
Okay.
If the matrix A is both symmetric and skew symmetric, both, okay, symmetric and skew symmetric, that means A transpose is equals to A and A transpose
Yes.
is equals to minus A, both needs to be fulfilled. That is the case, we must have a zero matrix. Okay, तभी हम बोलेंगे
Uh-huh.
0 plus 0, okay, एक ही बात है, it's the same thing.
Okay.
Okay, so we are done with matrices. Invertible matrix, just मैं एक ब्रीफ दे दूं क्योंकि इसके बाद हमारा कोई एक्सरसाइज नहीं है, जस्ट अभी के लिए इतना समझ के रखना है. तो इन्वर्टिबल
Mm-hmm.
मैट्रिक्स का मतलब होता है अगर हमारे पास एक मैट्रिक्स ए है,
G.
ओके, कोई एक ऐसा मैट्रिक्स बी हमें मिल जाए जो ए में मल्टीप्लाई होके हमें आइडेंटिटी मैट्रिक्स दे दे. ओके, AB multiplied together must be equals to identity matrix, and also BA multiplied together will be I only. तब हम बोलेंगे B is the inverse of A, और हम ये भी बोल सकते हैं A is the inverse of B, दोनों एक दूसरे के inverse है. Got it?
Mm-hmm. Okay.
ओके, तो ऐसे मैट्रिक्स एग्जिस्ट करते हैं. ओके, इन डेटर्मिनेंट्स चैप्टर विल बी डिस्कसिंग अगेन अबाउट दिस वन. यहाँ पे प्रॉपर मैट्रिक्स ए एन इनवर्स ऑफ ईच अदर, यहाँ